Now, because if that's the case, if that's the case, why is it that when you increase the voltage from 8 to 9, it's still nothing happened? If you change from 9 to 10, so let's take a look one more time. Right? Press R. This is a great discussion.
I'm tired.
Let's bring it back to 1, right? I'm going to press V to exit, and then look at here. This is voltage of 8, correct? One simulation, you created 1, 2, 3, 4, 5 unit of force, yes? And now I'm going to change to 9, as we did a few minutes ago. Or you went to 10, I'm going to simulate, nothing happens. I increase the voltage, nothing happens, right? And then I asked you why nothing happened. You came up with a couple of hypotheses. You said, maybe there is not enough calcium. And she said, maybe there is not enough head of the myosin. But then when I increased the number of stimulation, my contraction grew. Well, I tell you the answer, if you don't mind. Just to move on. Here's the idea now. I want you to listen. Look. Let's say this is a cell. And here's a nucleus. We're going to do this now, correct? And I'm just going to right. Here's the actin and myosin, correct? Yes? Inside the cell, we have endoplasmic reticulum. It's called what? Endoplasmic reticulum. It's an organelle. If you've never heard about this one, it's very simple. It's a bunch of sacs on top of each other, right? And inside this guy is what? Calcium is inside the endoplasmic reticulum. In the plastic reticulum, can you imagine just a bunch of sacs on top of each other? And inside you have what? Calcium, right? You got that so far? So when you stimulate the muscle, this calcium is going to get released and it's going to come here and make this contraction happen, right? Yes? As soon as the stimulation is over, as soon as shock is over, this calcium is going to come back inside the cell. We're going to suck the calcium back through active
transport.
Diffusion. I mean, active
transport.
But calcium doesn't active transport. So this is through the ATPase, basically. Correct?
It goes back into the cell.
It's going to come back inside the cell. Yes, in the plastic.
And the trigger is the lack of stim?
As soon as, okay, listen. As soon as I stimulate, you're going to learn in the physiology lecture how the channel is going to open and calcium is going to get out. As soon as calcium is going to come out, the pump is called calcium ATPase. You start working to suck it back in. Correct? So, if there is no more stimulation, the calcium is going to come back in very quickly. However, if there is a second stimulation, third stimulation, that is going to make you release more, yes? You understand what I'm saying?
Mm-hmm.
So if there's only one stimulation, you release some calcium out. As soon as the stimulation is over, the calcium is going to start coming back in. If there's a second and third and fourth stimulation, you keep pushing the calcium out. Calcium ATP is trying to bring it in, but the stimulation is going to make it what? Release more. Okay, you just know so far? Here's an idea you have to understand. If I have one stimulation, only one, boom, that stimulation, regardless of how strong the stimulation is, can open my calcium channel just for X amount of time. Let's say for 0.004 seconds, whatever it is. So one stimulation can open this channel, let's say I'm just thinking of for 1 second, correct? It doesn't matter how much you're going to improve or increase the stimulation. Maximum is going to be open for what? 1 second, let's say, correct? Because this channel is designed, after 1 second it's going to what? Close. So, 8 volts of the stimulation is going to open it for 1 second, 9 volt is going to open it for 1 second, 10 volt is going to open it for 1 second, because you reach the maximum of the time limited to stay this channel open. You understand that? If you want to release more calcium, to recruit more head of the myosin, you have to make sure this channel stays open longer. Because if it's closed, then the pump starts bringing the calcium back in, yes? So how are you going to keep this channel stay open longer? By number of the stimulation, not by the strength of the stimulation. If you increase the number of the stimulation, this channel is going to stay what? Longer, and therefore you release more calcium. So in other words, I want to tell you this one. You have enough calcium. You have enough head of the myosin. However, that 1 second is not enough to recruit all of them. Do you understand that? Do you get my idea? I'm going to repeat one more time. It's a tiny, tiny point, but very important. We have enough calcium, and we have enough head of the myosin, right? However, one stimulation only can open the channel for X amount of time. This channel is designed to close after some specific time, correct? So it doesn't matter how strong you're going to hit this muscle, this channel only stays up for X amount of time. When you reach the maximum, the channel is going to close. The only way you can keep this channel open is by what? Multiple stimulation. Multiple stimulation. Therefore, the calcium is going to release more, and therefore you're going to recruit more head of the myosin. Your contraction is going to improve. The reason that when you increase the number of stimulation, your contraction improves is because you are keeping the channel open longer. You understand that? That's it. Did you understand what I said? Because I'm going to ask you some for the exam. And I don't want you to say, okay, I'm confused. Answer is, the calcium can be released from a channel based on how long